Hi, my name is Geddes and I will be presenting the paper, Improving Color Patterns to Assist People with Colour Vision Deficiency. This work was done in collaboration with David Flatla, Garreth Tigwell, and Roshan Peiris. Colour Vision Deficiency, or CVD, affects roughly 5% of the population in some form. The most common type of colour vision deficiency is red-green CVD. The image on the right illustrates how individuals with red-green colour vision deficiency have difficulty distinguishing the red male cardinals from the brown female cardinals, due to this distinction being highly reliant on colour. Colour patterns are a way to assist individuals with CVD. They are beneficial due to supplementing the user while allowing them to still see the original image's colors. In this case, ColourMeters is illustrated. ColourMeters displays colors with a line based on the hue angle. A problem, however, can be seen where neighboring hue values can be very difficult to distinguish. ColourAdd is another color pattern. ColourAdd utilizes the base colors of red, yellow, and blue, using only 3 patterns. The advantage is that only 3 patterns need to be memorized, and further colors are learned as combinations of the base patterns. However, ColourAdd has some problems. It uses abstract symbols, which can be harder to learn, and it uses the same base symbol for red and blue, only differentiated by orientation. A direct problem of this can be seen with orange and green, which are commonly confused colors for individuals with red-green CVD. These symbols would be impossible to distinguish in a scenario where orientation could not be determined. Current problems that exist are that state-of-the-art color patterns are unintuitive, they make use of abstract symbology, and because of that they are often hard to learn and require a lot of knowledge to effectively use. Current tasks that evaluate CVD aids are focused on improving the comparative capability of color judgment, and because of this, very little tasks focus on color identification. We created ColourIconizer to create a pattern set which has symbols which are largely analogous to the colors they represent. This should require less training and provide an immediate use of this pattern set. We also created a pattern set called ColourMix, which looked to improve upon ColourAdd. We used 4 base patterns to allow for more colors to be encoded. Finally, we also used symbols that were roughly analogous to the colors they looked to represent, which should assist in learning this pattern set. Similar to ColourAdd, we encode further colors with ColourMix through combinations of base colors. This again allows minimal memory of specific patterns and instead requires users to learn methods that are applied to the patterns. An advantage that we have with an additional base pattern is that the color teal or blue-green can be represented, and teal represents a color which is largely confused for individuals with red-green CVD, as they often confuse it with gray. Beyond allowing secondary colors to be represented with combinations of base colors, with ColourMix, further more complex colors can be represented via the relative opacity and thickness of the line of the patterns. This allows for the pattern set to represent a continuum of colors. Please read the paper for more details on ColourMix. We created the selection task to evaluate the ability of an aid to allow an individual to identify a color by name with the support of color comparison. An important feature of our task is that the desired color can be absent. The image above illustrates this such case where the required color blue, in this case, is absent. Completing this task requires an aid not only to provide distinction between confusing colors when they are both present, but also when one is not present at all. The transition task was designed to require only comparative color usage. A user can complete this without knowing any of the color names. Also, as compared to other diagnostic tests which are similar in design, this does not aim to diagnose an individual with colour vision deficiency. This aims to only serve as a difficult task for individuals with CVD. The sorting task was designed to be done through identifying color only by name. This type of color identification is rather important, as a tool should allow an individual to determine a color independent of other colors. To evaluate our color patterns, we conducted an online remote study, where participants would independently complete the study. We created a website which allowed participants to complete our study online and anonymously. We obtained participants from Reddit and Facebook groups. In total, we had 29 participants with CVD and an equal 29 participants without CVD complete our study. Importantly, our tasks were strictly ordered so that the selection task was always first, then the transition task, and lastly the sorting task. This ordering was completed for each pattern. for which participants were randomly assigned a given counterbalanced pattern ordering. Participants without CVD did not use any of the patterns. From the chart for the selection task results, we see that ColourMeters assisted the least out of the 3 patterns. ColourMeters had the lowest accuracy and the longest completion time compared with ColourIconizer and ColourMix. Also of note, when using ColourMeters, participants spent more time on the task than in the control condition. Importantly, ColourIconizer and ColourMix both improved in accuracy over both the control and ColourMeters, but also decreased in completion time, unlike ColourMeters. In the transition task, as ColourIconizer was not designed to be a continuous tool, it failed to assist participants, but of interest, both in the CVD group and the ColourIconizer group, it looks like participants had very fast completion times even in relation to the non-CVD group. This likely means that participants gave up in these cases. Of importance, we see an accuracy-speed trade-off with the results of ColourMeters and ColourMix, where participants were happy to spend longer completing the task if they felt the aid actually assisted them. In the sorting task, when using ColourIconizer, CVD participants even outperformed non-CVD participants in accuracy. As interesting as this sounds, this could be due to the difference of naming between the chosen colors for the task and the names that our non-CVD participants perceive them to be, as we did choose some relatively difficult colors. Now importantly, ColourMeters really struggled on this task, especially in comparison to the CVD control. It can be seen that it barely assisted participants over not using the patterns at all. The main advantage it provided was speed, allowing participants to name colors a little bit faster than without patterns. Contrary to ColourMeters, ColourMix again performed well on this task, and this was again likely due to the patterns being more distinct and recognizable. To summarize, different pattern designs are better suited for different uses of color. In the case of ColourIconizer, it performs especially well on tasks requiring color identification by name. However, at the same time, because of the lack of granularity in its design, it fails at tasks where comparison is required. On the other hand, ColourMeters performs well in comparison-based tasks, and poorly at color name identification tasks, and this is due to the difficulty in mapping a color name to the abstract symbols of ColourMeters. Finally, ColourMix performed relatively well at all tasks. The goal was to try to incorporate the benefits of ColourIconizer, ColourMeters, and ColourAdd. And while it may not be able to outperform ColourIconizer on naming tasks, there is the remaining question of how training could benefit it.